Okay, so this is the second part of the same thing. Okay, so I just want to show you how you can answer the same question now in the different using the different formula. So if you have been given the number of moles, but instead of the mass of the substances or the element, so how can we find the concentration of such solution? Okay. Now, I want you to note that I'm going to use the same example. So, we are using the same example, okay? I just want to show you how you can find the same, using the same question, okay? How you can answer it, okay? After finding the number of moles, okay? So, let's just say, for example, we have been given the number of moles but not the mass, okay? So as you can see, the formula changes to concentration equals to moles over the volume, okay? In which this is going to be okay. So the final units will be moles per decimeter cubic, okay? Now, the first step that we're going to do is for us to understand that in question 1, the mass was 2.5 grams. And then the volume was, and then this was copper 2 sulfate. So in question 1, the mass was 2.5, and then the volume was 10 decimeter cubic, and then the name of the substance was copper 2 sulfate. So after you have gathered such information, or you have actually collected that information, what you need to understand is that the formula, or rather the formula, or rather the question is saying that find the concentration in moles per cubic decimeter. Okay, so our final answer should be in moles per cubic decimeter. Now the question here, or rather the problem, is that we don't have the number of moles. So what we're going to do is, first of all, find the number of moles, okay? So if you are watching this video and you don't know how to find the number of moles, I did a video previously on how you can find the number of moles. So please check out that video so that once you come back to this problem, it is actually going to be very simple and straightforward. But nevertheless, I'm going to show you how you can find the number of moles in a given substance, okay, like copper 2 sulfate. Okay. So the formula is that N equals to mass over Mr. So this is the formula for finding the number of moles. Okay, so the number of moles equals to the mass over the relative molecular mass, okay, of a substance. So what you do is, we have to find the relative molecular mass of copper. So copper 2 sulfate. And this is the chemical formula for copper. So this is going to be, okay, so oxygen is 4 multiplied by 16. Sulfur is 1 multiplied by 32. Copper, there is only one copper, multiplied by 64. Okay. First of all, what you do is you get the answers there. So this is so 4 by 16. The 4, it's 2, it's the 4. Okay. Now after you do that, 4 by 16 you get 64, and then 1 by 32 you get 32, then 1 by 64 you get 64. And then now you can now add this. Okay, so you can add them now. 64 plus 32 plus 64, we have 160 grams. Okay. So after you add them, you get 164. Okay. So you say now from there, what you do is this number that you've gotten, you say 160 grams per mole. Okay, so the reason why I'm saying per mole is because we are just using 1 tin of the copper to sulfate. So what you do is 160 grams of copper to sulfate is as the relative molecular mass, meaning the combined elements that makes up the copper to sulfate. So that is the copper, the sulfur, and then the oxygen. So once we sum up those, then we get 160 grams of 1 molecule of the copper to sulfate. Okay. So from there, the number of moles goes to the mass 2.5 grams over 160 grams per mole. Okay. So what you do now is this and this goes. Okay. Now n equals to 2.5 divided by 160. Okay. So you get 0.01562 moles. Okay, so those are the number of molecules that makes up the copper to sulfate, 0.015625 moles. Okay, and then once you do that, now you're going to say therefore concentration equals to moles over the volume. Okay. So the moles over the volume, and then this is going to be, so the moles you put that one, 0.0015625 over, now the volume is 10. Okay, so 10 cubic decimeter. So what you do is you go to your calculator, then divide by 10. Okay, so you're going to have 1.5625 times 10 to the power minus 3. Okay. So mole per So that's how you can now express the concentration of something in terms of moles per cubic decimeters. Okay, so make sure that first of all you have to convert the mass that you have been given to the number of moles. And then once you have converted that, then now you can use the concentration, the other formula for concentration, when you are only required that the final answer of the concentration should be given in moles per cubic decimeter. Okay, so I want you make sure you practice. It may seem to be very difficult or tough, but please, I encourage you that once you go through, you practice, and then everything just going to flow like water, or like something that is very very smooth. So this is how you can go about using this other formula of concentration, moles per cubic decimeter. So first of all, take note of the numbers, the quantities that you have, the mass, the volume. So first of all, convert the volume, convert the mass. So this 2.5, which was that one, gave us, we found the number of moles. And then now from there, we also had to find now the concentration in moles per cubic decimeter. Okay, so now this is how you could have answered question 1 if the answers was required in form of if the final answer was required in form of moles per cubic decimeter. Now, before we answer the last question, I want you to understand that so what I want you to understand is that if the units of concentration are expressed now in moles per volume or moles per cubic decimeter, then now the way we be calling now this concentration will now change from a concentration to molarity. Okay, it will be called we'll be calling it molarity. Okay, so it will be called molarity. So make sure that you understand when the units of concentration are expressed in moles per cubic decimeters, that concentration is now called molarity. Okay, it is now called the molarity. So I want you to understand. Now, what is the symbol for molarity? Okay, so the symbol for molarity, for example, this same number, I'll write this same number is 1.5625 times 10 to the power minus 3. Okay. So now you write the capital M. You write it in capital M. Okay. So you write in capital M. More examples. So if, for example, I say 2M, 2 capital M, and I say 0.1 capital M, maybe C, maybe 5.5 M. Okay. So what I want you to understand is that the units are now more specifically tied or attached to moles per cubic decimeters. Okay, so please make sure you understand that. Okay, so this is 2 moles per cubic decimeter. So the 2 capital M meaning 2 molar, okay, or 2 molarity, okay. So this is going to be 2 moles per cubic decimeters. So even this one is going to be 0.1 mole per decimeter. Even this one, 5.5 mole per cubic decimeter. So it's just the same thing, but in order to, without wasting much of the time, the units can be just written as whatever the number is of the concentration, and then after the number you put the capital M. So anyone who have done concentration or the mole concept will be able to understand that how I'm talking about moles per cubic decimeter. The 2 molar, I'm talking about molarity, okay? So that's how you can go about understanding that stuff. Now for question 2, let's now finish up with question 2, how you can solve the same question by, giving out the final answer in moles per cubic decimeter or in moles per volume, okay? That means concentration or rather molarity, okay? Okay, so now we are going to answer question 2 in form of moles per cubic decimeter. So the information that we had was, and by the way, I'm just using the same example that we did, and then how can we now give out the answer in moles per cubic decimeter? Okay, so we were given that the mass was 5 grams, and then the volume was 0.02 decimeter cubic. Remember, the volume was converted from cubic centimeters to cubic decimeters, and that's how we ended up having 0.02 decimeter cubic. And then also the compound that we are looking for, that we were given was sodium chloride, or rather the substance, and that's a chemical formula, sodium chloride. Okay, so the first thing that you're supposed to do is you find the number of moles. Okay, so number of moles equal to mass over number of moles, meaning the N, equals to the mass, and then over the relative molecular mass of the sodium chloride. Now, how can you find the relative molecular mass of sodium chloride? Is that you just have to do the same thing we did for copper 2 sulfate. So this, that. So there is only one chlorine multiplied by 35.5, and then sodium is 1 multiplied by 0.3. Okay. So what you do is what you now do is 1 times 35.5 is just 35 plus 1 multiplied by 3, you get 0.3. And then you use your calculator, you add all together 35.5 plus 23. This is going to give you to give you 58.5 grams per mole. Okay, so that is the relative molecular mass, or in shortcut we call it the Mr. Okay, that's how you have seen. I'm just writing the Mr. Okay, but sodium chloride, the Mr. or relative molecular mass is 58.5 grams per mole. From there, what do we do now? What we do is that now we come back to the same formula. So the mass is this one divided by 58.5. Okay. So this goes, the mass will cancel, and then will remain with the mole, or rather moles. Okay, so mass will go, and then remain with the mole. So 5 divided by 58.5 get going to get 0.085. Okay. So the first thing that you're supposed to do is convert the mass that you've been given into moles. And then now you use the formula for concentration. So that is concentration equals to moles over the volume that you have. So that is molarity, okay? Therefore, concentration equals to moles. Okay. So we have the number of moles. So we put there 0.085 over, what is the volume? 0.02. Okay. So now you use your calculator. Okay. This is going to be 0.085 divided by 0.02. Okay, so you get 4.25 molar. Okay. So remember, I've written capital M when the units of concentration are expressed in moles per volume or moles per cubic decimeter. The answer you get becomes molarity. Okay, becomes molarity. Okay, or in other words, the number after you punch everything, you get 4.25. You write capital M. That's all you have to do, and that's how you can answer that question 2 in terms of moles per cubic decimeter. Okay, so that is that's all under concentration, but there is one key concept that has remained, which is dilution. Okay, so the next video will be about dilution, and I hope you have enjoyed this video. Please, if you have not subscribed to my channel, make sure that you do subscribe so that whenever I do post a video or anything on my Facebook page, on my YouTube channel, you'll be the first person to actually receive all those updates or notification. Please share to your family, to your friends, relative, and whoever is actually interested in this, and you also think that they might also need this video content. Okay, so this is the Radical Academy. It's bye bye, and I'll see you in the next video.